Okay, another video. This time I'm going to talk about Openfoam and the residence time distribution. And here, I did it because I was trying to think of a way to verify some of my simulations with the real world data. So I decided to let's try residence time distribution, but I'm not going to talk about that, what it is, because that's beyond the scope of this little show here. So I can either use Openfoam to predict an RTD and then compare it to the real reactor. I can go the other way and use a real reactor, and once I calculate all the dead zones or bypassing from the residence time distribution data, I can just say, hey, that's good or bad. And I can go to the next one. And for the simulation, I used the same geometry and collection data method as the previous studies. In this, I used the tracer pulse concentration. I used this one. The air in the reactor, I had CO2 as the tracer. I used it 1 atmosphere and room temperature. I assumed aluminum flow. I had the same combination of solvers except for temperature transfer. I used mass transfer coefficients. And here's the geometry of the simulation sequence, the same one as before. And here's a little picture of the potential flow field, which is what I always start out with. I have another video, I'll go into detail about these flow fields. It's a lot better than just this. Okay, and so this is a tracer. This is what that looks like. As you can see, it started, I turned off the pulse. I can let it run. And you can sort of see how the concentration changed where the, okay, go to the next video. Okay, and this is the results. You can see with just the potential field, I have a flow present time of 135 seconds, 0.6, and with I had increased the flow a little bit to 0.05 meters per second. Didn't change much on the mean residual time. So that's how that one looked. And go to cumulative distribution times, looked the same. Nothing unusual about these. And then I guess I had to go, all right, so I increased the time for another one, and you can sort of see the time decreased the amount, and we have the residence distribution curve sort of shifted towards a shorter period time. And here's the residence time, cumulative residence time distribution function. Nothing exciting there. And okay, that's it. Well, in the future, I might just optimize this more. I might even combine it with my heat transfer simulations to see if there's any simulations, or I'll just try something else. And that's it for this one.